Video 2. Why would intelligent tutoring software use item response theory? And a quick review of where we've been and where we're going. First, where we've been, the user experience. Khan Academy asks its users questions, and future questions are determined by previous responses. It somehow decides which questions to ask which users. How? Item response theory. Where we're going right now. We're going to look at why would intelligent tutoring software use IRT in the first place. The answer is because IRT can resolve problems faced by less sophisticated approaches to measuring proficiency. I'll use the word proficiency. Also in the IRT world, you'll see people who use the word aptitude or ability interchangeably. And then in video 3, we're going to look at interpreting item parameters, and in video 4, we're going to see how to take these item characteristics and build tests effectively. Let's introduce some new vocabulary. Keywords. The first one is domain, and its definition is a body of knowledge or a specific kind of aptitude. For example, this could be your proficiency in long division, which would be a very narrow domain of something more general, such as 7th grade mathematics. Another example of a domain would be the ability to identify the countries of the world. Or instead of the ability to identify the countries of the world, I could define essentially the same domain as knowledge of the countries of the world. The next word is sample, and I want you to think of a sample as a subset of the domain, and ideally a representative subset of the domain. In the case of long division, while we may be interested in this domain of the ability to solve any or all long division problems, a specific sample would be maybe 20 long division problems, which are, part of the domain, but it's really a subset. It's not the entire domain or the domain itself. The next keyword is item, and that is the basic unit comprising a sample. So for example, a single question on a test. I mentioned those 20 long division items, 20 long division questions. I'm using all those terms interchangeably. Lastly, we have the word test, and that is basically the same thing as a sample. It's just a collection of items. We can think about a test as an exam when you're sitting in class. We can also think about a test as a sample of items from a domain. All right, let's walk through an example, albeit a rather extreme example. Let's say that a geography professor wants to know her students' knowledge of the names and the location of all the large cities and every country on Earth. So the domain here would be the name and location of every country and large city on Earth. And let's say for this test, she's decided on a very long geography test where she's going to make her students name and locate every country and large city on Earth. So an example of an individual item would be this. This is the first item on the test. And the test would proceed this way, basically going through comprehensively and being asked to name all the cities and countries on Earth. So several hundred items later, the professor would have a great sample from which to estimate student knowledge of the domain. In fact, if students didn't have inconsistent memories, they never guessed correctly by chance, they didn't get fatigued during this extremely long exam, then you could argue that the sample was equivalent to the domain in this case, and the scores truly measured student proficiency of the domain. Also, this test would be totally fair because everyone got the same exact items. But obviously there are buts. Here are a few specific ones. The first is that that's a lot of wasted time. Not only is it a lot of time, but it's a lot of unnecessary time, because if you can identify Mumbai, it seems unnecessary to ask you to identify India. And conversely, if you can't identify India, it seems unnecessary to ask you to identify Mumbai. Another problem is that some domains are essentially infinite. Think about a multiplication test. If I wanted to test you on your knowledge of 4-digit multiplication problems, that would go on for an extremely long time. So I'm hoping that your inner psychometrician is urging you to take a sample from the domain instead. It's very reasonable. But the key question here is there a best sample? Are some items better to use than others when we're trying to measure knowledge of a domain? And how could we know this statistically? Here's where things get interesting. Let's introduce some item response theory vocabulary. Keywords. The first one is item difficulty, which is generally how likely is it that the average test taker will respond correctly to an item. More precisely though, item difficulty is going to tell us how proficient an individual needs to be in order to have a 50-50 chance of answering the item correctly. The next word is even harder to define precisely at this point in a non-mathematical way, and that is item discrimination. And I want you to think of this as how effectively does this item distinguish between more and less proficient individuals. Next, we're going to talk about the characteristics of a good sample. So what do I mean by a good sample? One characteristic is the items shouldn't be too difficult or too easy. The item should be representative of the domain. There should be enough items to yield sufficiently precise measurements of proficiency in whatever it is that we're trying to measure. And the fourth is that items should be discriminating, so they're an efficient representation of the domain. Let's go over these one at a time. A good sample is not too difficult and not too easy, because if items are too easy, then we're not able to estimate whether an individual would be able to answer a more difficult item correctly than what appeared on the test. Similarly, if a test is just too hard, then we're not able to estimate whether an individual who may not be super proficient in an area would be able to answer some easier items correctly. You might be thinking that there's an obvious solution to this, and that is to have some easy items and some hard items. That's what you're accustomed to seeing probably through a lot of your college career and through high school tests. But I want you to stop and consider for a second if there isn't a better solution. Feel free to pause the video if you want. We'll get back to this later. Another characteristic of a good sample is that it is representative of the domain. And when I say representative of the domain, I mean truly representative of the domain. So if you take the example from the geography test, the way that we defined our domain is knowledge of large cities and countries from the entire world. And think about a sample where too many of the countries and cities that are sampled are from Europe, or too many are from Australia. And we have test takers from all over the world taking this exam. The problem we encounter is that we are no longer only measuring proficiency or knowledge of countries and cities for the entire world. The problem is that people from Europe may be more likely to know geography in Europe, and people from South America may be more likely to know geography from South America. So instead of our sample truly being representative of the domain, it becomes representative of something else, a different kind of domain. Perhaps it's a good measure of our domain among people who are from a certain region, but generally it wouldn't be a good way to compare people from all over the world. One way to get around this problem is to take a random sample. By taking a random sample, you ensure that on average, you're not being unfair towards any individual group. But the problem with this approach is that still, for any given sample, it's very plausible that it will be working in favor of one group or against another group, and not a true and accurate measure of proficiency in our domain. Taking a random sample or hand selecting a representative sample works fine on a small scale, but on a large scale, item response theory offers you the opportunity to select to make sure that your items are all measuring proficiency in the domain. Also, a good sample is large enough to yield estimates that are sufficiently precise given your purposes. And so the relationship between the number of items on the test and the precision of proficiency estimates looks something like this. You can take a look at three different regions of this line. And so there's an area where it's a lot flatter, there's an area where it's very steep where I'm drawing now, and right in the middle where I kind of circled things, you can see that it's between those two. And the main idea with this figure is that at the very beginning, precision increases a lot, and then after you add so many items, it doesn't increase as much per item. And the fourth characteristic of a good sample is that it is discriminating, meaning collectively the items are an efficient representation of the domain. So a good and discriminating sample will tell us which individuals would do well on a really long test and which individuals wouldn't do so well on the really long test in the fewest possible items. The more discriminating the items, the more quickly we can figure this out. Let's work through an item discrimination example. Take a look at the screen. What country is this? If this were an item on the test, I'm guessing that some of you would probably say Italy. Wrong. I was looking for Vatican City. So sorry. Vatican City is technically a country, and if you look at where that arrow is pointing, it seems to be pointing to this area right in the Rome area. There's a little hexagon shape. Oh, definitely the answer was Vatican City. You may be thinking, what a ridiculous item, but in fact, it's legitimately part of the domain of interest. But how well do you think this item would discriminate among people who know more and less geography overall? Probably not so well. Compare this to Italy. Now, Italy may not help us discriminate between a geography enthusiast and a true expert, but it may effectively discriminate between people who know very basic European geography and people who know very little or none at all. A good sample will have more items like Italy and fewer items like Vatican City. Alright, time to review. What is a good sample? It's not too difficult and it's not too easy. It's representative of the domain. It's large enough to yield sufficiently precise measurements, and it is discriminating. It might have already crossed your mind that Khan Academy doesn't need to restrict itself to a single version or a single sample. They can have multiple versions of a test and they can give multiple samples to different people. And this has huge advantages. It's much more personalized. For example, someone with a higher level of proficiency can be matched with more difficult items. If you can identify Mumbai, Khan Academy doesn't need to ask you to identify India. Having multiple versions of a test also has challenges. One of the key ones is, how do we fairly compare proficiency for people who took tests of different difficulties? And how do you know whether someone should get a test that is easy, medium, or pretty difficult? Should Khan Academy start off giving users super easy items and make everyone answer those first? What are the best items to give someone first when you don't have any idea how proficient they are? These are some pretty tricky measurement problems to resolve. An ideal solution would be a technology that can estimate difficulty and discrimination for each item, automatically create different versions of tests that take into account previous responses, and that yield scores that allow instructors a fair way to compare students who received different sets of items. An item response theory, when used properly, can take care of number 1 and number 3. And with number 1 and 3 taken care of, number 2 is far easier to accomplish. Alright, that's all for today. Back to the roadmap. Item response theory. Where we've been, we talked about the user experience in video 1. In this video, we looked at why would intelligent tutoring software use IRT. The short answer is that it solves a measurement problem that less sophisticated approaches can't. In video 3, we're going to look at interpreting item parameters, difficulty, and discrimination. In video 4, we'll be bringing it all together and test building.